Hello, welcome to our lesson once again on differentiation applications. And this time around, we are going to look at tangent and normal to a curve. Tangent and normal to a curve. Okay, so what is a tangent and even what is a normal? Okay, a tangent is a straight line that touches either a circle or can be a curve at what? At a point, okay, as we already know. So if I have a curve, and let's say that I have a line a straight line which is touching the curve at a point. Okay, so there's a tangent. So this straight line here is touching the curve at this particular point. Okay, let's see, my point is x and y. Okay, it's touching the curve at this particular point, so this is a tangent. Okay, and what we should know is that if, let's say, the function of the curve is, let's say the curve is quadratic, as squared plus bs plus c. Okay, so this is the curve, the function for the curve. So if I differentiate this particular function here, all right, then the differentiation of the curve, okay, becomes the gradient function. So if I differentiate this particular function dy on dx, actually I'm going to get 2ax plus b, because a, b, and c are constants. So I get 2ax plus b. The differentiation of this function, which is 2x plus b, okay, becomes what? It becomes the gradient function. So if I want to find the gradient, okay, of the tangent, then the gradient of the tangent can be found or can be obtained by substituting the point, okay, at which the tangent touches the curve. So if the tangent touches the curve at this particular point here, then if I substitute, okay, the point into the gradient function, then I will get the gradient of what? Of the tangent. I'll get the gradient of the tangent. All right. And if that is the case, then I can also be asked to find the what? The equation of the tangent. The equation of the tangent. So I've gotten my gradient, and then let's say the gradient after substituting the value of the x into this particular function. Let me say I'll get my gradient. Okay, so let's say the value I get for the gradient of the tangent, okay, after I have substituted the point into the gradient function, is what? Is m. My gradient becomes m. If that is the case, then the equation of the tangent, okay, implies y minus y1 equal to m into bracket x minus x1. I believe we all know this. This is an equation of a straight line. All right, and because the tangent is a straight line, that is why the equation becomes like this. Okay, so the m is the gradient of the tangent. Okay, the m is the gradient of, so this is the equation of the tangent. Okay, where your y1, all right, and then your s1 is the point at which the straight line touches what? Touches the curve. Okay, and then get your y1 and then your x1. Is that okay? Because that is also a point on the straight line. It's a point on the curve at the same time point on the straight line. Okay, so that becomes my x1 and y1. Okay, so that is about the tangent. And a line that is perpendicular to the tangent, okay, is the normal. So this can be my normal. Okay, the normal. Okay, so the normal is a line that is what? Is a straight line that is perpendicular to the tangent. Alright, it's perpendicular to the tangent. And if the normal is perpendicular to the tangent, then gradient of the normal, okay, becomes what? The negative reciprocal of the gradient of the tangent. Okay, so the negative reciprocal becomes 1 minus 1 over m minus 1 over m. So that is the negative. The reciprocal of m is 1 over m. So the negative reciprocal becomes minus 1 on m. Minus 1 on m. So that will become the gradient of the normal. If the gradient of the tangent is m, then the gradient of the normal becomes what? Minus 1 over m. Minus 1 over m. Is that okay? Then we can find the equation of the normal. So equation of the normal becomes what? Implies y minus y1 equal to 1 over negative 1 on m s minus s1. So this also becomes what? The equation of the normal. And take note, the normal, because the normal is perpendicular to the tangent, they all have the same what? The same point. There will be a point, the point s and y, okay, or s1, or let's say s1 y1. Okay, so this particular point s1 y1 will be a point on the curve. It will be a point on the tangent, and it will also be a point on the normal. Okay, so the same point on the curve, the same point on the normal, the same point on the tangent. So that same point can be used to calculate for the equation of the tangent. That same point can also be used to calculate the equation of the normal. But take note, the gradient of the normal is what? Is the negative reciprocal of the tangent. Okay, the negative reciprocal of the tangent. So that is how you can also get what? You can also get the equation of the normal. The equation of the normal. I think this is so clear for us to understand. So we are going to solve some questions right away. All right. Okay, so let's solve the questions. Given that y is equal to s cube minus 4s squared plus 5s minus 7, find the y on the x. Q is a point on the curve where x is equal to 3. A, find the y coordinate of Q. B, calculate the gradient at Q. Okay, so we are going to solve the questions. All right, go through them one by one. Okay, so first of all, we have to find the y over the s, which is the gradient function of the curve y. Okay, so y is equal to s cubed minus 4s squared plus 5s minus 7. Find out the y on bs, and take note the y on bs is the gradient function. Okay, the y on bs. So this will give us a 3s squared minus 8x plus 5. This will be 0. Okay, so you have 3s squared minus 8s plus 5. Okay, so this is our dy on ds. And he's saying that Q is a point on the curve where x is equal to 3. Okay, so on the curve of this cubic function, there is a point Q on the curve. and the point Q on the curve at that particular point, x is 3. At that point, s is 3. So it's referring to a point on the curve where s is 3. And it says we should find the y coordinate of Q. We should find the y coordinate of Q. So A, if there is a point on the curve, this is our curve, where s is 3, okay, and we are looking for the y coordinate, then we substitute the 3 into the main function, not the gradient function. If you put the 3 into the differentiation, you get the gradient at where s is equal to what? At where s is equal to 3. But if I want the corresponding value of the y of the point Q, then I have to substitute the 3 into the main function here, not the gradient function. The gradient function gives you the value of the gradient. But if I want at the point where s is 3, what is the corresponding value of y? And I have to substitute the 3 into the main into the main function. I believe you get it. All right. So I'll find the y coordinate of Q. The s coordinate is 3. Let me the y coordinates. Okay. So if s is equal to 3, it implies that my y is equal to 3 cubed minus 4, 3 square plus 5 multiplied by 3 minus 7. Is that okay? So 3 cubed minus 4 and then 3 square plus 5 and then multiply by 3 minus 7 will be equal to negative 1. Okay. Equal to minus 1. Minus 1. Alright. So the y coordinate of Q is negative 1. So we can say that point Q is what? Is 3, negative 1. Okay, so our point Q is 3, negative 1. Because the y coordinate is what? The y coordinate is negative 1. So when you substitute 3 into the this particular the function for the curve, we get negative 1. So our point Q is 3, negative 1. So the s coordinate is 3 and the y coordinate is negative 1. I believe that is clear. Okay. B. Calculate the gradient at Q. So we are going to calculate the gradient at Q. What is the gradient function? Our dy on the x is 3s squared minus 8s plus 5. So the gradient will be equal to, we substitute 3. So with the gradient, okay, it involves, the gradient function involves only x. There is no y. So we substitute the s what? The s coordinate. So the s coordinate is 3. So 3 squared minus 8 times 3 plus 5. Alright. Okay, so 3 by 3 square will give us 27 minus 8 times 3 is what? 24. Then plus 5. So 27 minus 24 plus 5 will give us 8. Okay. So the curve s minus 4s squared plus 5s minus 7. At where s is equal to 3, the gradient is what? The gradient is 8. I believe that is clear. Okay. So let's continue. Right. So C. Find the equation of the tangent at Q. The equation of the tangent. So C. So equation of the tangent. The tangent, I said find the equation of the at Q. So the tangent is the straight line, okay, that touches the curve at a point. So it is touching the curve at a point what? At a point Q. Or we are finding the tangent at a point what? At a point Q. And because it is touching the curve at the point Q, then it means our gradient is the 8. Alright, our gradient is the 8 because the tangent is also on the point 3, -1. Because it's at the point Q. So the gradient will become 8. So the equation of the tangent, you know, y minus y1 go to the gradient s minus s1. Okay. So y minus. So our point Q is 3, -1. So y minus y1. So this become our s1 y1. So our y1 is 1 negative. So y minus -1 equal to the gradient 8 and s minus 3 s1. So it becomes y plus 1 equal to, so we can expand this. 8 times x is 8s. 8 times 3 is what? Is 24. Alright. Then our equation, if you like, you can bring all at one side and equate it to 0. Okay. Or you can say y is equal to, any way you like it to write the equation. So let's bring all at one side and equate it to 0. So we have y, okay, plus 1 minus 8s plus 24 equal to 0. So we bring 8s here become minus 8s, and then plus 24 here become minus 24 here become plus 24. Okay, so it means that we have our equation as y minus 8s 1 plus 24 become plus 25 equal to 0. So this can become our, or this is our equation on what? Equation of the tangent. Or as I said, or if you like, you can say y is equal to, you bring y to this side, 8s minus 25. So this can also be the equation of the tangent. Alright, so let's continue with D. So D, let's continue on this side. Find the equation of the normal at Q. So equation of the normal okay, so we know that the gradient of the normal is the negative reciprocal of the tangent. So the equation of the normal too, we will have y minus y1 minus 1 on m s minus x1. Okay, so y minus, what is our y1? That is minus 1. Okay, so take note that the normal too is on the same point Q. Okay, equal to minus 1 over 8. Okay, so that's our gradient is 8. So the normal is the negative reciprocal of the tangent. So minus 1 on 8 x minus 3. Alright. Then we are going to have y plus 1 equal to minus 1 on 8 x minus 3. Then 8, you can take 8 here. So you have 8 y plus 1 equal to minus 1 x minus 3. Okay, so I have 8 times y to be 8y, 8 times 1 to be 8 equal to minus 1 times x to be minus s, minus 1 times minus 3 to be plus 3. Alright, okay, let's continue on this side. So we have 8y plus a equal to minus x plus 3. So we can bring out one side and equate it to 0 as we did for this. So we can have what? 8y plus 8 plus x minus 3 equal to 0. Okay, so 8y plus 8, this will be plus x, this will be minus 3 equal to 0. So we can have what? 8y plus x, 8 minus 3 will give me plus 5 equal to what? Equal to 0. Alright, so we can have 8y plus s plus equal to 0. So if you want to take all to one side too, you can say 8y equal to minus s minus 5, or you can also make y the subject and then So this can be our equation. Okay. The last one, find the values of s for which the curve has gradient of 5. Find the values of s for which the curve has a gradient of 5. So on the curve, okay, we need the values of s, and at that particular value of s on the curve, the gradient will be 5, not 8. Okay, where the gradient is 8 is at where s is 3. That is where the gradient is 8. Now we are going to look at the values of s where the gradient is what? Will be 5. So you take the gradient function, okay, which is this, and then you equate it to what? You equate it to 5, and then you are going to get the values of what? The values of s. Is that okay? Alright. So it means that what is the gradient function? 3s squared minus 8s plus 5 equal to 5, and then you find the values of s. So you bring this one this side, so you have 3s squared minus 8s plus 5 minus 5 equal to 0, because we are going to the quadratic. You have 3s squared minus 8s equal to 0. 5 minus 5 is 0. Then you factorize what is the common factor? That will be x. I have 3x minus 8 equal to 0. So either s is equal to 0 or 3s minus 8 equal to 0, which also means that 3x is equal to 8. And we can say x is equal to what? 8 on 3. So the values of s for which the gradient will be 5. Okay, therefore the values of s is equal to 0 or 8 on 3. So these are the values of s for which the gradient is going to be what? The gradient is going to be 5. Is that okay? I believe this is understood and it is so clear. Alright. I know I will see you again in our next lesson. Enjoy your day. Bye bye.